Okay, graphing trig, and then this is working backwards to make a trig equation. Okay, so we have a maximum of 5,300. And then we're going to hit a minimum at 15,100. And we're going to make an equation that has sine in it and cos in it. Okay, so there's kind of my format. I'm going to put an A in the front, a C in the bracket, sorry, A in the front, B factored out, C and D, right? That's where we would put stuff. Okay, so here's what I do. The first thing I do is I ask myself, what height value falls in the middle of this graph? Height. There's a height of 100 down here and a height of 300 up there. 200. Okay, where do I fit that into the equation? Do you remember which place? The D. Where have we shifted this graph? Because the middle was normally 0 flat. Now it's 200 up. Okay, next thing I do is this. How much have I amplitude? That's the word, remember that? So how much do we have to go above it and below it? That's an amplitude. So we need to fluctuate by 100 above, 100 below, right? So that is my stretch, my A. Okay, next I'm going to talk about this period. Remember the word period? That's how long it takes to go through a cycle of a wave. Okay, so how much time have I done here? I went from a 5 and then to a 15. So you answered this before. We've moved 10 spaces, right? Would you classify that as moving through a cycle? No, because that only takes us half of a wave, so we would have to continue and land back to a top, which would mean I've now moved how many spaces? So the period equals 20. So now, how do I figure out my B value? So I'm going to do this little formula, which is, what's the normal cycle? 2 pi over some kind of B would equal the period. So you switch those around. So 2 pi over 20. If you do the crisscross. Okay, I'm going to do a pi over 10. Because that's just reduction. You can just leave it as well, that's fine. That would have been a full point. So do you notice how everything I put into the sine or the cosine is still the same? But the C is different. So we have to talk about, we'll do cos first. How do you start a cos curve? What position? Top. And what is the top's location? We have shifted to the right 5, so minus 5. Now, sine. How does a sine curve start? Middle? What about this middle? No. It can't be that middle because it has to head up. So this is an option, right? Middle upward. Or over here, right? I have a few options. I could have been here, or I could have been here. So let's get some x values. So if this is at a 5, this is at a 15. Well, what's this one? Going to be right smack dab in the middle there. 10. This is, so what's happening each time? 5, 10, 15. So this is 0. This is 20. So you could leave it. You don't have to write anything then, because you could just go 0. Okay? Could have had a x minus 20 in there. You could have just left it for a 0. What's the next number you could have put in there? X minus 40, x minus 60, x minus 80. Those all are answers. Okay, drawing an angle. When you draw an angle, you need two things. You need to show me where it is and how it's swiveled. So, first of all, negative means I'm heading, swiveling downward. I'm going to swivel that way, negative. And 7 pi over 8, you don't have a calculator. How do you draw that? Okay, here's my thought process. 8 over 8 is the same thing as doing a what? A full pi, right? A 1 pi. 7 over 8 is just less than that. So I'm going to do just less than a pi. Does that make sense, what my strategy was? Basically, if this is 1 pi, you're going to go 7/8 of the way there, right? So that's full points. You showed me where it was and how it swiveled. State a positive coterminal. What does that mean to you? Another way to get to the same spot. How do we, that's positive. So how do we move in a circle to the same spot? How much do we have to rotate to land in the same spot? You have to rotate one circle to land in the same position. How do we measure one circle as a value? 2 pi or 360 degrees. Okay, but, well, we're not talking about degrees out of this at all, right? Okay, so here's what I'm going to do. I'm going to rotate a circle. Okay, can we revamp 2 pi to look different, just to match my fraction stuff going on? 16 pi over 8. See what I'm doing there? 16 over 8 is the same thing as writing a 2. So now, what is negative 7 plus a 16? 9 pi over 8. Is that positive? Yes. Okay. Do you understand if I drew that, what it would look like? So if I went 9 pi over 8, that's just a little more than a pi, right? So that, if I drew it, that's what it would look like. Does that land the same as that landing? Yeah. Okay, but you guys are good with this understanding? Remember the 2 pi situation? Match it with a fraction. Okay. Determine the arc length. So this question is a calculator question. So you would have that little symbol. If you get an arc length question, it's almost guaranteed that it's going to be probably at the start-ish. Oh, look. Yep. Arc length question. Look at that. It has a calculator on it. It's almost, if you get it, it's on the start of your test. Okay, so here's what we know. This is on a formula sheet. This is on your formula sheet, which means arc length. What do you know about the angle when we use this formula? When we use this formula, it has to be in a radian. And then this is radius. So don't be confused, radian, radius. Okay? Be careful. How could they probably trick you? They might give you a diameter. Don't be tricked. Diameter, radius, right? Okay, so here we go. Arc length equals 130 degrees, which I don't want. I'm going to convert it. Do you remember how to convert? Times by, what's the conversion between the degrees and the radians that we always used? You divide by what you want to get rid of. So I would like to get rid of degrees. So I put the 180 as a divider. And that's the conversion, right? A pi is 180 degrees. Divide, that's exactly what Moses says. Always divide by what you want to get rid of. So backtracking the other way, if I'm in radians and I want to go to degrees, I would flip that around, right? Okay, 3.5 is the radius, so we don't have to do work there. This would be an entire calculator, do it all at once.
In the questions, did they ever say like what unit it is? Like will it be like that fraction? Or like
No,
okay.
no.
So weird. Did the wrong thing.
They will not do that. Okay, please don't make me deduct points for rounding. Just round properly so I don't have to deduct. 7 point, but I will tell you the good news. Let's say you rounded wrong in question 1. I have to deduct half a point. And then you rounded again wrong somewhere later. Now that one doesn't matter. So.
Wait, say you like did your unit circle way too fast and you messed up one and you used that for like everything. You would do the same thing.
Yeah, then I have to take off for the entire thing.
The entire thing.
Yeah. Because I'm not looking at your unit circle. That's rough work. I'm not looking at it. So make sure you have that unit circle nailed. What'd you get here? 9, 4, 1. Okay. And I have to take a half a point off now as well because they didn't put centimeters. So rounding, that's a half a point. And forgetting units, that's a half a point. So I've done this before. This question will be out of 2 points on your exam. And somebody will have done the whole thing right. And then if they round wrong and forgot their units, now they're at 50%. See how quick? Like for that question, right? Okay. We have an angle that is in quadrant 2. You got your astica down? We're in quadrant 2. We were told cosecant. Okay, So here's my understanding. I need to know what's X, what's Y, what's R. So what are we doing? So you're really cute. X-rated. Thank you. Excellent. Okay. Cosecant is the flip of okay. What is the X, Y, R stuff with the sign? So you're really. Okay, so then if I'm this, that means an R and that means a Y. Okay, so that is what's going on. Okay, if you had accidentally done it with the 3 and the 2 reversed, because that was, you forgot, would you understand that that doesn't make sense? Your hypotenuse has to be longer on a triangle, right? Okay, I'm going to put positives and negatives on this thing already. What do we know about an R value? Always positive. What do you know about this 2 is a Y value? Is it a positive or a negative?
Positive.
What would you put on this x-axis?
Negative.
That's a good thing to note. How am I going to get there with Pythagorean? Should we add or subtract?
Subtract.
So 3 squared subtract 2 squared. I do not have a calculator, so I have to do this in my head. 9 subtract 4 is 5. Square root. Is that a nice pretty number? No. So what do I do?
Leave it.
Leave. Which is good because you don't have your calculator anyway. And my final question is, what is the tan of this angle? So what do you do for tan letters? So you're really cute. Thank you, X. Okay, please also remember what the Astica thing is all about. If Astica is in quadrant 2, your tan value should end up how? Negative in quadrant 2, right? Okay, finding exact values. So I need you to think of 2 things with exact values. Where are you and what are you looking for? Where are you and what are you looking for? Okay. 11 pi over 3. Where am I? Okay, so let's rotate. If you went that far, what is that going to be? 3 pi over 3. If you went a full circle, 6 pi over 3. And then another would be 9 pi over 3. And then 12 pi over 3. I don't want to do that. Too far. So where should I land? (11 pi over 3). So I'm going to look at my hopefully accurate unit circle that you've made yourself. I'm looking at 300 degrees. That's where I'm going to look. And This is sine. So the what? What do I do with sine? Y. Y over R. Why did you not tell me about the R?
Because it's always 1.
Because it's on a unit circle, it's 1. So y, so what am I doing? Negative root 3 over 2.
Don't say that. Because I'll finish it.
Okay, 4 pi over 3, I'm not going to do that because it's just on, right? I already know the where. 4 pi over 3, boom, I got my where. What? What is the secant all about? Cos flipping. So what am I going to do? I'm going to take my x value. Cos is x value. And what am I going to do with that x value? Flip it. So here we go. 4 pi over 3. X value, which was negative a half. So now it's going to be negative 2. And the last one, negative 5 pi over 6. So where do I actually land? So negative 5 pi over 6 means that direction of rotation. So where do I land at the 7 pi over 6? And I'm going to tan it. So what does tan tell me to do with numbers? Y over x. So y over x. Okay, so I'm going to do some work here on the tan. Okay, I'm just going to focus on this tan division. What happens when you add a negative number, negative number? This is positive. What always happens with the 2's? Cancel. So I'm going to write 1 over root 3. I'm going to take that and that, because the negatives canceled, the 2's canceled on the flip. Okay, final answer. What kind of value is it, positive or negative as a final? Positive. And can we cross off root 3, root 3? Can I cross off 2 and a 2? Okay. Actually, everything crossed out.
Equals
1. Positive 1.
1.
Oh boy, equation solving. Okay, when you're doing equation solving, you have to have your grade 11 foundation page mastered. Remember that pink paper I gave you? Here's the algebra. Okay, so tan squareds and tans, that's 2 variables. So what should I always make sure when I have 2 variables? When I have 2 variables, I need to do a equal 0. So we're good. Now I develop my strategies. Is this factorable would be my first question. Yeah, let's try it with a simple. It is factorable. What do I do if I can't factor something? Quadratic formula. Then you can cry if that also doesn't work. But one of those should work. Okay, so here's another thing. If you forgot your equals 0 there, half a point. If you forgot to put the theta symbol there, you've lost your variable. Or if you accidentally used an x instead of a theta on this question. Variables are important. Equals zeros are important. Okay, I'm going to go to this one. I don't need a calculator for it. So here's my question. Which quadrant would you be in if the result of a tan was positive? You're in 2 of the quadrants, which 1 and 3. Tan goes diagonal, right? Remember? Cos is x, so how do you split x? Left and rights. Y is sines, so how do you split up and down? And tan, diagonals. Okay, why didn't I need a calculator? It's where do I divide to be 1? Right there, because what's this y divided by this x? 1. Okay, how should I answer this? What's going on here? What's going on with that thing?
Any real number.
Any angle ever, forever and ever and ever. So I'm going to go pi over 4. How do you go on forever? Plus, okay, you could do this one in 2 different ways. You could do plus 2 pi k, kei, and also this one. Okay, if you answered like that, that's good. That's good. Or I could have been even smarter, and I could have done just a pi k as a, so you could have had this, you could have done those 2, or you could have just answered as a this, because why? If I rotated just a pi, don't I include that answer? Yeah. So then now I don't need to do the extra answer. Okay, now this is something I ran into on a provincial. You know what they used to represent integers? We've been doing i's. I think in the British, because some of our government stuff is probably from the British textbooks, they used a Z. You don't, yours is good with an I. But what if it was a multiple choice question, which is where I saw it, and then they put a Z in there, and everybody was like, what's a Z? And I had to Google it. I didn't even know. So that was the British version of integer.
But like, where do you have to use the Z?
Like, there was a multiple choice question.
People running out wiki stuff. Okay. Yeah, but like if we see a Z in a multiple choice, it can be correct.
It just means there was an integer. I don't remember where I saw it. Yeah, I don't know. I saw it one place. Okay, now this one, I actually have to use my calculator to solve that. So, grab your calculator. What are you going to first do? We're going to go in radians. So I'm going to go into radian mode. I'm going to be in radian mode. I'm going to 10 inverse the 4. Okay, so I'm going to show you again the two ways you could have wrote your answer. You could have had them separated. So you could have wrote it as two of them separately with a 2 pi k, or a 1 with a pi k. But I wanted to practice, how do you get this actual position here? What do you do to your value? Pi plus. So I just wanted you to practice that value. So this pi k thing only works with tan, right? It'll never work with a sine or a cos, because that's, tan is the diagonal. Okay, so why did I pick that question? It threw a lot of reminders at us. It had us thinking about this thing. Astica is back. How to get into positions. How to change your calculator mode. Yes. Do you guys know how to notice how I did 3 decimals? Right? 3 decimals. Okay? Never ever round until the end. So I wouldn't have done pi plus a rounded number. I would have had this in my calculator, plus pi. Okay, number 6. Please look at the question and tell me what's the problem here. There's something I can't really do right now. I have 2 things going on. This is a sine thing and this is a cos thing. That doesn't really work out for us. We can't have a bunch of different variables like that. So, what? Subs. Where should I look for subs? On my formula sheet. Where do you think I'm specifically going to look? Squared stuff. Okay, so I see this on my sheet. Okay, I would like to revamp that. What should I do? I'm going to move that over. Now, if this is equal to sine squared, I can substitute it. Do we remember that skill? Substitute an equation. Does that make sense? Okay, so 2 bracket substitution. Two bracket substitution. What should I do in my next phase? I should distribute that. step 1 distribution. Step 2, I collected. There was a 2 and a 1, so I put that together. What do you think I hate about solving this one right now? I don't like a negative boss, so what could I do to change it? I'm just going to times everything by -1. Okay, so now I'm good. I have just this cos squared and a cos. I have 2 variables, but they're the same idea, at least, right? Not like before with the sines and the coses. You can't do that. Equals 0. That's good. Now I'm going to try to factor. This would be a, what style? Complex. Okay, so I'm going to try. If it doesn't, it's a formula, right? 2 cos and 1 cos. I need to put a 3 times a 1 in the brackets at the end here somehow. And then we're going to play around with our FOIL, right? Do you have a FOIL that would work out? So let me check here. 2 cos squared minus 6 of them plus 1 of them. Does that work out? Minus 6 of them, positive 1 of them, and minus 3. Okay? It's one of my pet peeves when somebody factors wrong because you have no excuse. Because what can you do to check out your factoring? FOIL it. Does it FOIL to that? You should always know how to do that. Okay, cos theta is -1/2 there. Cos theta is 3 there. I'm going to do the 3 answer first because it's super fast. No solution. Okay, you have to physically write that. If you left it blank, assuming that there's no answer, I have to deduct you. So you have to write that in there to let me know. So cos is x values. What's the largest x value you can ever get to? 1. Yep. That's the largest x value, right? So cos inverse of 3 is going to give me an error, right? Yeah. Cos. Same with sine, right? 1 or -1 is the biggest. And tan is more, right? Also, what does a sine or cos curve look like? What's the highest height a cos curve goes? 1. Right? Okay. Which quadrants would you be located in if cos x was negative? The left sides, 2 and 3. And I'm not provided my calculator on this question. Peyton, get the thing out of your hand. I haven't used my calculator because this is on a unit circle, right? The half. So what am I looking for? -1/2 as an x value. So I'm going to write down what I'm looking at, but this is not my answer, okay? Okay, so this is what I've seen on my unit circle, but that's not my answer. Because I should go back to the question and think about how I need to answer this. Okay, so in the question, it told me this angle answer had to, first of all, it has to be in degrees, right? But my answer has to be in this domain. So what do you know about 120 degrees? It's not in my domain. So there's been one answer to this question. 240 degrees is the only thing that's a good answer. Okay, tell me what your instinct is if you ever see an angle divided by 12. What'd you say? Run? Run. Is that something on our unit circle? No. 3 and 4 are on a unit circle as dividers. 6 and 2, whatever, those are all dividers, but 12 is not on my unit circle, so what do I know? So we have those values on our unit circle, so where would the 12 values be located? Either there, right? Or there, or there. Anything. These are the 12ers. They're the in-between sections, which means they are based off of increments of? What's between here? What's this value right here?
I don't know. 9.
Degrees. Give it to me in degrees.
15.
15 or?
75.
That's what it is. Okay, so this would be a pi over a 12. Do you remember what this would be? Well, this is a half of a pi, so how many 12s is that at the top? 6, so this is 5 over 12. What would this location be? 7 over 12. This is a full pi at the 180 line, so that's a 12 over 12. So this is 11, 13. What is the bottom 270 part if you're 1.5 pies out of 12? 18. So this is a 17, 19. A full circle would be 24, 12, right?
Yep.
So this would be 23. Okay, so do you remember all that? Anything that has a 12 on the bottom. Okay, so we are here. Okay, so we are, as a referenced amount, this is a reference. How far am I away? 15 degrees. So I think that because the question was in radians, you have to keep radian language. So I'm going to be doing the sine of 15 degrees, okay, but I just wrote it with a radian value. So we can't just do the sine of 15. It doesn't exist. What could we use to make a 15? 45 and 30. So I would have to do 45 minus 30. So I'm just going to write these as radians though. Sine of 45 minus 30. That's the same thing as doing sine of 15. Okay, so what would my next maneuver be? Grabbing my formula sheet. Where are you gonna work here? This. So I'm gonna be doing the sine subtraction. So sine A cos B subtract cos, wait, I did this number, this is a 4. There we go, that's a 4. I'm like, that something's wrong. I'm going to get 4 brackets. And I'm going to replace those with exact values, trig values. Okay, when I do this, I kind of cheat a little bit, and I just put the 45s in there. Because what is the cos or sine at 45? Root 2 over 2. Root 2 over 2. So this is 30 degrees. What is the cos? What's the x value? Root 3 over 2 and 1 over 2. So when I'm doing fractions, what's the common bottom of the fraction? 4. 2 times 2 on this bottom, 2 times 2 on this bottom. Everything has a bottom of 4. And this makes a root 6 minus root 2. Okay, not done because I have to ask myself about Astica, because I did the sine value for 15 degrees, which is not actually where I am. So then, what do I have to do if I am in this quadrant? I have to negate my answer. Okay? Do you guys understand your sine values? So, for instance, because I'm here, 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 let's look in here. They all have the same references. They all have 1/2 in the y values, but it's just a matter of positive or negatives, right? That's all you're changing. Okay. The only other kind of question you might see here is if I did like a cosecant or a secant, what would you do? You would just be flipping this to put the 4 on the top. And
But do you know what the answer